So now we want to look at a very important theorem in algebra and mathematics in general. This theorem we call the remainder theorem. Alright, before I go to the remainder theorem exactly, let us look at dividing two natural normal numbers that we used to. Natural numbers, right? Let's say we want to find out the value of 2 into 9. So 2 divided into 9 of 4 times, and then we can say do the long division, 4 2s, we can say 8 minus 1. And we have a name for all of these things, right? We have a term. The 1 is what we call the remainder. Alright? So 9 divided by 2, you get a remainder of 1, right? Remainder. The 2, we call it the divisor, right? The 9, we call it the dividend. Alright? And the 4, we call it the, is it quotient? Yes, quotient. In other words, another way of rewriting the dividend is 9, put it down here, 9, you can say 9 is equal to the divisor times the quotient, 2 times 4, right? Plus the remainder, which of 1. You can always rewrite 9 like that. Alright? So, let me get a little bit more abstract now. Before I get abstract. So 9, so that's a dividend. Call it dividend is equal to the divisor times the quotient plus the remainder. Alright, so the dividend, which in this case is 9, is equal to the divisor times the quotient plus the remainder. And that is always the case. Now, let's separate this. Let's get a little bit abstract now. So if I have a function f of x, so this was the case of 9 over 2, right? 9 divided by 2, right? That was the case there, yes? We're looking at 9 divided by 2. Now, suppose you have a case where you have f of x, a function, divided by x minus a. Now we ask ourselves, what would this be equal to? Then, definitely, this would be equal. So the f of x is the quotient, right? Dividend, sorry. F of x is the dividend, is what you're dividing by, and x minus a would be the divisor. So if I ask you f of x over x minus a, divide f of x by x minus a, what you will end up with is, yes, so what you will end up with, before I go to what we'll end up with, let us remind ourselves of something. So if I ask you what's 9 divided by 2, let me not put the actual values 4. What you end up with is the quotient. With the quotient, let me put what you end up with first, actual values. You'll end up with 4 plus 4.5, right? 9 divided by 2, that's 4.5. So let me write that's 4 plus a half. Still 4.5, right? So what the 4 represent is the quotient. So the 4 represent the quotient. Let me write Q. Plus, remainder was 1 over the divisor. Alright, over 9 divided by 2 over the divisor, which of course would be 2. The divisor was 2, alright? So just match it to this. So 9 divided by 2, that's 4 plus a half, where the quotient is like the 4, and the remainder was 1, and the 2 would represent the divisor. So in the same way, you divide a function by f of x divided by x minus a, which is the divisor. What you get is a quotient. Now I write q of x, just keep it as q. You have a quotient plus the remainder over the divisor. In this case it was 2, in this case it is x minus a. Alright? Now I'm going to times each term by x minus a, so I'm going to multiply each term by x minus a. And so we'll end up with x minus a times the left hand side there. So with x minus a times f of x over x minus a, and then x minus a times q, or you want x or q times x minus a, whichever, or that is not important when I'm multiplying, and then r over x minus a times x minus a. So we multiply x minus a times each term, and what we'll have now, x minus a into itself gives us 1, so we'll have f of x equal to q times x minus a plus r. And then if I should find f of a, so f of a is equal to q bracket. Now f of a means you replace the x with a, right? So f of a would be q bracket a minus a plus r. So let me just continue up here. Just continue up here. So that means f of a. Now the bracket will become 0. So all you have now is r. That's what the remainder theorem states. Alright, so the theorem states that if f of x is divided by x minus a, as we have here, then the remainder r is given by the formula r equal to f of a. Alright, that's pretty much what the remainder theorem says, right? So once you divide a function by x minus a, the remainder is given by f of a. I'm going to also look at some examples where we actually find remainder by long division. But let's try and apply this theorem to some situations here. Wait, so before we attempt to answer any questions, I also want to be good, because the remainder theorem is really two theorems in one. It's really two theorems, what we call the factor theorem, which is no different from the remainder theorem, technically, because what the factor theorem says, I copy the same thing here, right? If x minus a divides into f of x without leaving a remainder, or another way of saying this is of leaving a remainder that is equal to 0, alright, then x minus a is a factor of f of x. In other words, if you're asked to find the remainder and you found f of a and you get r to be 0, let's say f of a is equal to 0, then it means that there's no remainder, which means that x minus a is a factor. If you have a number and you divide 2 into 8, and so 2 into 8, you wouldn't get a remainder, would you? It would mean that 2 is a factor of 8. In the same way, if x minus a divided into f of x and you don't get a remainder, or you say the remainder is 0, then x minus a is what we call a factor of f of x. So it's just an extension of the remainder theorem. So it's a factor if r becomes 0. Alright, so there are basically 2 in 1. In the next video, we're going to look at some examples.